Welcome to The Explainer. Okay, today we are diving into a 1977 deep space mystery that honestly continues to completely baffle astronomers and challenge our fundamental understanding of the cosmos. We're going to explore the story of the night the universe literally seemed to call out to us, and the nearly half-century of frantic scientific detective work that followed. Let's get right into it. So, picture this. It's the night of August 15, 1977. While the whole world was totally distracted by the rise of Star Wars and the launch of Voyager 1, a massive radio telescope sitting in a quiet Ohio field silently recorded a really startling anomaly. Ohio State University's Big Ear radio telescope picked up a signal that lasted exactly 72 seconds. No more, no less. It grew in intensity, it peaked, and then it diminished before vanishing forever. And the crazy thing? Nobody was even watching the live feed at the time. The machine was simply doing its job, printing out its data onto these long sheets of continuous paper. In fact, it wasn't until days later that a volunteer astronomer named Jerry Ehman actually sat down with those printouts to analyze them. He's sitting there, scanning through rows and columns of numbers, just looking for anything out of the ordinary in the telescope's automated sweep of the sky. And when his eyes finally caught this specific 72-second burst, he was so completely stunned by what he saw that he instinctively scrawled the word "wow" in red pen right there in the margin. He accidentally named the event in that very moment, and, well, the legend of the wow signal was born. Now, take a look at the exact data Jerry Ehman was holding. Pop culture often misunderstands this infamous string 6EQJ5 that he circled as some kind of decoded alien alphabet. But actually, scratch that. It's not a message at all. It's just a measurement of signal intensity. See, the Big Ear encoded signal strength into numbers and letters. It started at 6, jumped to E, which means 14 times the background noise, then Q, U, which was an incredibly powerful 30.5 times the background noise, and then back down to J and 5. So this isn't a hidden word. It is a perfect intensity bell curve. It's the exact mathematical shape you would expect from a deep space source sweeping precisely through the telescope's beam as the Earth rotated. To really understand why this intensity spike was so mind-boggling, we have to talk about the frequency it arrived on. The signal landed at roughly 1420 megahertz. Now, why do scientists care so much about this exact frequency? Well, because this is the hydrogen line. Hydrogen is by far the most abundant element in the entire universe. So back in 1959, pioneering physicists suggested that any technologically advanced civilization trying to send a universal beacon would logically broadcast exactly here. It acts as a kind of cosmic meeting frequency that any intelligent society out there would instantly recognize.
And that is why this signal was unprecedented. It literally hit an absolute cosmic trifecta. First off, it behaved exactly like it arrived from a fixed point out in deep space. Second, it was narrowband. That means it was confined to a very tight little slice of the radio spectrum, unlike the messy, broad emissions you get from standard natural cosmic events. And third, it landed exactly at that theoretical hydrogen line frequency. It was essentially the holy grail of what researchers believed an intentional alien beacon would look like.
But, and this is a massive but, here we run into the central paradox of our mystery, the deafening silence. Almost immediately after the discovery, astronomers scrambled to find it again. They pointed the Big Ear right back at the exact same spot in the constellation Sagittarius. Nothing. Years later, much more powerful telescope networks like the Very Large Array listened intently to that region. Still, absolutely nothing. This agonizing non-repetition makes the signal incredibly fascinating, but just so scientifically frustrating. Because in science, if a phenomenon cannot be reproduced, it's incredibly difficult to study and confirm. Section 1. Ruling out the suspects. Let's take a look at some of the more mundane explanations. So what wasn't it? Well, we can actually firmly cross several mundane suspects off our list based purely on hard physics. It absolutely wasn't a moving aircraft or a satellite, and it wasn't a piece of space debris reflecting signals. Why? Because those would produce a Doppler shift, a change in frequency as they move, which this signal completely lacked. It also wasn't standard terrestrial interference because that 1420 megahertz band is globally protected. And interference just doesn't produce that perfect deep space bell curve shape. And despite a very popular theory floating around in 2016, it wasn't a passing comet because comets produce broad emissions, not the sharp narrowband spike we saw here. Which leaves us with the two reigning heavyweights in the debate today. On one side, we have the extraterrestrial intelligence hypothesis.
This is the chilling idea of a genuine alien transmission that perfectly matched our own theoretical predictions. On the flip side, we have a highly exotic, naturally occurring cosmic alignment, the magnetar hydrogen cloud maser hypothesis. As scientists, we really have to impartially weigh both the possibility of alien technology and the possibility of incredibly rare natural astrophysical physics. Now, fast forward a bit, because modern astronomy and archival analysis have dramatically revived this cold case over the last few years. In 2020, an amateur astronomer actually pinpointed a sun-like star about 1,800 light-years away as a possible origin point. Then, in 2024, observations using data from the Arecibo Observatory's RED survey, which monitors specific stellar emissions, detected similar, though weaker, signals in interstellar clouds. And by 2025, massive scientific plot twists began to emerge, publishing revised intensity levels for the original signal and even launching whole new observational networks. Section 2, the 2025 Magnetar Breakthrough. Let's look at a fascinating natural explanation. To really understand this breakthrough, we first need to define our prime natural suspect, the magnetar. So what is a magnetar? It's a hypermagnetized, hyperdense neutron star. Picture the city-sized remnants of a massive star that went supernova and exploded, leaving behind a core that carries a magnetic field quadrillions of times stronger than Earth's. Crucially, these extreme objects can occasionally release unimaginably powerful, sudden bursts of radiation out into space. The second piece of the puzzle here is something called a maser. Now, you know what a laser is with visible light, right? Well, a maser is microwave amplification by stimulated emission of radiation. It is basically a naturally occurring radio frequency analog to a laser. And masers are known to naturally exist out there in interstellar gas clouds, acting like giant, naturally occurring microwave amplifiers in the sky. So put those together, and you get the exact causal loop hypothesized by the Arecibo team. Here's how it works. Step 1, a magnetar violently flares. Step 2, that intense, sudden burst of radiation sweeps through space and energizes a nearby cold interstellar cloud of neutral hydrogen. Step 3, through a process called superradiance, which is a rapid, synchronized burst of energy, the cloud briefly undergoes stimulated emission, firing off a powerful narrowband maser beam right at that 1420 megahertz hydrogen line frequency. In this scenario, the Big Ear telescope just happened to catch this incredibly rare, temporary, super bright signal at exactly the right 72 seconds. Then, in August of 2025, exactly 48 years after the original detection, which is pretty wild, the Arecibo team successfully validated their work by publishing a massive reanalysis of archival SETI data using modern techniques. They successfully confirmed the signal's extraterrestrial, deep space origin, and amazingly, they proved the signal was actually significantly more powerful than anyone originally calculated back in 1977. Now, while this doesn't definitively close the book on the mystery, it sets much firmer scientific limits and gives serious credibility to this natural yet highly exotic cosmic chain reaction. Section 3, the search continues. Let's look at what the future holds for this mystery. Because time on large, professional radio telescopes is incredibly expensive and super limited, researchers have recently launched the WOW at Home initiative. And this is just a brilliant, hopeful development. It relies on a distributed network of affordable, small radio telescopes operated globally by citizen scientists and amateur astronomers. The goal here is simple: put as many eyes on the sky as possible. A network like this significantly increases our odds that if another 72-second anomaly, or a magnetar flare, or hey, even a genuine technosignature ever flashes across our solar system again, we will be watching and ready for it. Yet, amidst all this forward momentum, there is a surprising and kind of heartbreaking epilogue about the instrument that started this whole thing. In 1998, the historic Big Ear telescope, the very machine that recorded our most compelling piece of cosmic evidence to date, was actually torn down and demolished by real estate developers. And to build what? A golf course. Seriously. It's a tragic little detail that really emphasizes the sheer fragility of our scientific history. Ultimately, exploring the WOW signal forces us to confront the famous Fermi paradox. The physicist Enrico Fermi famously asked, if the universe is so vast and teeming with the potential for intelligence, where is everybody? Why is it so quiet? The WOW signal remains our most profound brush with this exact question. Whether it was the blinding flash of a magnetar-energized hydrogen cloud, or an actual literal beacon from a distant world, it leaves us with a haunting thought.
What happens when the universe finally calls, but we only catch a single 72-second whisper? What else might we be missing right now?